In this vlog, we'll be continuing our implementation of a neural network by implementing the other components you would typically find in a neural network. So to guide us, I've created this document that contains, I actually use this document in class, which contains a sample problem that that computes for a neural network, right? Wherein it trains a neural network so that weights are adjusted to minimize the error or the output. But we won't be doing the feed forward and back prop yet, but rather we'll be implementing a neural network set of layers as well as the matrices. So if you can see the diagram right here, what I want to achieve is to be able to have something that represents a layer, right? So any neural network will have an input layer, an output layer, and a bunch of hidden layers in between. Wherein the input layer will hold the neurons containing the input values coming from your data set, and the output layer will hold the predicted values, the neurons containing the predicted values. Aside from implementing the layers, wherein layers should be simple, they're just a bunch of, they just contain a set of neurons. The next thing we'll implement is a matrix class that will represent the set of weights. Okay, so aside from implementing the matrix class, that matrix class should be able to transpose or return a transpose version of itself. So let's say for A transpose, let's say you have this matrix 3 by 2. If you try to transpose it, it becomes something like this, and if we try to transpose this, it goes back to the original form. Okay. And then after that, we'll implement the entire neural network class to tie everything together. Okay, so I'll start with the layer class. Okay, so I'll start with the header file. Okay, I'll just copy the entire layer header file. Neuron layer. Okay, and all this layer will do is that it will, well, at least for the constructor, it should have a parameter that will dictate how many neurons are contained in this layer. So I'll have something like int size. Right? Probably have a private variable called size right there. All right, so once the layer knows its size, it should be able to instantiate the vector or the list of neurons. I'm using a vector for this one. Okay, a vector of neurons wherein the size of this vector is the int size parameter that we passed with. Okay, so it needs to know what neuron is. And then once we construct a layer, okay, so we include layer.hpp. Okay, so the constructor will look something like this. Loop through the size value for int I equals 0, I is less than size, I plus plus, create a new neuron, say 0 value, and then push it in the neurons vector. So push back, I think, push back in. Okay, of course, we set the size, this size to size, right? Okay, so that's the only implementation we have for the layer. Okay, yeah, I think that should work, hopefully. Well, we can test it out. We'll first try to compile this thing. Make set val. All right, I actually tried to implement, I actually forgot a method that I'd like to implement for the neuron, which is the set val method, which will help us set a value, because these neurons have initially, let's say we create the output layer, they'll have a value of 0, but in the case of the input layer, you'd like to set the value for that neuron. So I did a function here called set val. Okay, whose implementation should rather be simple. It should be something like this. Set val, oh, I forgot void, right? Void neuron set val, double val, pass the value to the current value, and then proceed to activate and then derive the value again. Okay. Alright, so that's it for that, and let's try to see if we can compile this. Alright, so it compiled, so I guess the layer is working, right? Let's move to the more complicated object, which is the matrix. Okay, so a matrix is just a container for a set of numbers for rows and columns. And what I'd like the matrix to do is I'd like it to be able to return a transposed version of itself. So we can actually test that, right? Aside from that, whenever we instantiate a new matrix, we'd like to have the values randomized from a range of 0 to 1 to represent the weight values of that matrix, or of a given network. Okay, so to do that, I'll first declare a matrix HPP file. Copy this from that. You don't need that. For all layers, become matrix. And then for all layer, become matrix. Okay, so the parameters needed for the constructor of our matrix will be the size of the column, so the size of the rows, num rows, and the size of the columns, num cols. And I'd like to include a value, a Boolean value called is random. So if I pass true to it, then it will have a bunch of random numbers. If I pass false to it, it will just initialize a new matrix with 0 values. And the actual variable that holds those values together will be a vector of doubles. So I'll just call it values. Okay, need to include vector right there. Okay, so I'd also like to keep track of the num rows, so I'd probably have something like num rows, num cols, and maybe I won't need to keep it is random. Okay, so aside from that, I'd also like to have a transpose function, right, that returns a matrix, all right, a pointer to a matrix. What else? Oh, I'd also like to have something like get or set value. So void set value, pass to it the index of the row, the index of the column, and the actual value. Okay. Same goes for get value. You return a value based on the row and the column index. Set val, get val. Okay. Alright, so let's try to implement these methods here. I'll try to implement the constructor first. Okay, so include matrix.hpp, matrix int num rows, int num cols, bool is random. Okay, so well, I need to have a random number generator, so I'll probably have something like double get random number, or not get, but generate random number. Okay, so I think I'll need to implement this one first. Let's do something like double matrix get a random number, get random number. Okay, so we can have any implementation we'd like here inside get random number, but I'll actually use some notes for this. I should have a function somewhere here that allows me to get the random number. See if I have it here. Should be somewhere here. Oh, I can't find it. Let's go ahead and search how we can generate random numbers. No, don't like to open my mail. Close that. Close. Okay, random numbers 0 to 1. Right, so right. I think I used something before called somewhere here in my notes. Just look for it. Right, so I have it right here. The way I implemented random numbers before in C++ is by using std random, right? Std random device rather, rd std mt19937 gen rd. You can just copy and code from an old project. And I'll be using a uniform real distribution, right? Is 0, 1, right? And then what I return will be a random number. Yeah, I think it's this. Yeah, all right. Okay, so that's the implementation for a random number. We'll test it later on to see if this one is actually correct. Now for the matrix class, when a new matrix is initialized, of course, set first the num rows is equal to num rows, num calls. Well, actually, since we're setting it, we should have a way to get those values. So in num rows, what we can do is we can just program those simple getter functions inside the header file. So something like get num rows returns this num rows, and get num calls returns the it want everything, just this one, returns the number of columns. Okay, so that's something you can include right there. All right, so once we have the number of rows and columns, we will loop through the rows. Equals 0, I is less than num rows, I plus plus, have another one for columns, call this J. Okay, so once we loop through the we're looping row wise and then looping column wise for each row. For each row, for each column, we generate a new random number. So double R is equal to this get random number, right? Well, actually, if is random, meaning if this is a true value, then we generate that random number. Else, but actually, what we can do is we'll move double R here to be 0. Right, and then R is equal to get random number. Okay, so if is random is set to true, then it becomes a random number. Afterwards, we insert it to our values, which is a vector of doubles. So, well, actually, we need a vector of double here, which will correspond to my call values, the column values. Okay, so for each number generated, I'll push back to my call values, the variable R, and then after ending the loop for the columns, I'll push call values vector into values. So this values dot push back call values should give me my row of vector of my row of vector of doubles. Okay, so when we create a new matrix, that will be initialized right there. And what I'll do is I'll have another function called print to console, right? So something like void print to console. And what this will do is it will print the values of the matrix, right? So matrix print to console. Okay, right, so how can we print this matrix? Well, we can loop through the rows and then print out the number at this values. Well, actually, we're doing the same thing, right? We're looping through the rows and we're looping through the columns. This will be especially useful when we start debugging the network at let me just close this first. At j, right? You print out that value and then print double tab, I guess, right? Before printing a new line. Will this work? Yeah, I think it will work. Print to console. Okay, anyway, we can test this out. Okay, so that's the implementation for print to console. Initialize a matrix, loop row call wise, random number r, push back to call values, push to values. Okay, so I guess we can test this now. What I'll do is I'll include matrix. I'll just like to test the matrix function out. Well, again, just like the other example, let's just make sure that it compiles. Okay, it's compiling, so I'll create a new matrix. Okay, and I'll follow this one. The first matrix is actually a 3x2 matrix. Excuse me. Right, a 3x2 matrix. So I'll have something like int. Well, I just go ahead and have that matrix. Matrix M is equal to new matrix 3x2, and I'd like it to be random. Right? To see if this works, print to console. Okay. Right, so let's compile this. Oops. All right, undefined reference to matrix because we haven't included it in our CMake lists. Right. Let's include matrix. Matrix. All right. Compile. Oh no. Oh. Matrix.cpp. Oh, this one. I. All right. Okay. Compile that. Class matrix has no member named get random number. Did you mean generate random number? Yes, I meant generate random number. So where's that? There we go. It should be generate random number. Generate random number. All right. Okay, let's just clear that again. Compile. Still not working. All right. So if we wanted to use the random number generator that we did, we have to make sure that we include a header file called random. Okay. Try it again. All right, so now we have it right there. If we try to run this, then we have this matrix, a 3x2 matrix with random values. Now to test the transpose function, I want to do something like matrix m transposed is equal to transpose, right? And then we'll print that to the console. Print to console. And I'll just have something like a line, a line here, right, to separate the two matrices from each other. All right, so we need to program the transpose function of our matrix, which is essentially flipping the matrix. So I'll put it right here. What does it return? It returns an instance of a matrix. Transpose. Right, so what this will do is we'll create another matrix. M is equal to new matrix, and then pass to it the rows of this matrix will become the columns, or the size of the rows for this matrix will be the size of the columns of the current matrix. So in this case, this num calls. and then this num rows. So we're actually flipping, we're switching the dimensionality of the matrix for the transposed version. Okay, and then what I'll do is I'll do this. I'll have false for is random because I only want to set a bunch of zeros. Okay, and then what I'll do is I'll loop through the matrix again, the current matrix, so num rows and num calls, but this time setting the values for M, the new matrix, a transposed matrix, and say set val. Do I have a set val function? Alright, set value, right? They have an implementation of that. Okay, I don't have an implementation for set value, so void matrix set value in R and C double V, and all this is doing is that for the values variable at R at C, equate it or assign it the value of V. Alright. And then for get value, that's just something like, well, we can implement it here actually. Set value will just be this. Okay, I'll just copy this. So we won't have to implement it in the CPP file. And then get value will just return this values at R, at C, and there. So we won't need this. Right. So we'll set value for the matrix at, we're flipping the dimensionality. So the calls become the rows and the rows become the calls. So JI, right? The calls become the rows and the rows become the calls. Set value, JI, to be of value this get value at GI. Right, set value right there. Okay, and then of course we return M. Okay, so let's see if this transpose function works. In the main function, right, we try to transpose it, and then we print the value. So we should see a flipped version of our matrix. Whoops. Matrix at line 49. Matrix.hpp at line 49. Oh. Values 19 rather. All right, so we compile this again. Okay, print it. Okay, we have an out of range exception. Why? Okay, let's try to review the implementation. Set value GI. Get value. Oh, sorry. It should be get value ij. Right. It's the same thing. All right, now it's different. It's different. All right, so we have it right there. Compiled successfully. Just make sure. Okay, so did it flip? All right. This one is here. This one is over here. Right, so I guess the transpose function is working. This one is over here, this one is here, and this one is over here. Okay, so our transpose function is working. Right, so we have a layer, we have a matrix, and we have a neuron class. The final class I'll be implementing is the actual neural network class. Okay, so for neural network, layer becomes neural network. Layer neural network. All right. So for a neural network, what I want to do is it will have a topology. So vector int topology. It should know what the matrix is, as well as what a layer is. Okay, and whenever we create a neural network, we pass the topology to it. So the topology is given by this one, right? It's just an array of values, integer values, that corresponds to the size of neurons in each layer. So each index in the topology will correspond to the index of the layer, the layer's index rather. Okay. Okay, so what I want to do here is it should have a vector of layers, right? As well as a vector of matrices. So let's call this weight matrices. Alright, so we have something like this. Alright. Okay. So the reason why I wanted it to be a matrix, rather a vector of matrices, is because this one, right? I want to store this matrix and this matrix as well. So looking at the pattern, the number of weight matrices in a neural network will actually be the size of the topology minus 1. So if you have a topology of size 3, right, 1 input, 1 output, and 1 hidden, then the number of weight matrices will be 2, so n minus 1. Okay. So using that information, we can then start to code the neural network class. Okay, so we include NeuralNetwork.hpp, neural network, pass to it a vector of ints, topology. Okay, so include vector. All right, so we'll loop through the topology less than topology.size I++. Well, actually, I'll have the size of a, wait, where's that? Neural network HPP. Probably have int topology size. So I can actually store the topology size. So we have this topology size is equal to topology.size, so that we can just call topology size here. A bit of premature optimization, or I don't think it's actually needed, but maybe we can use it later on. All right, so the contents of a topology at a given index will correspond to the number of neurons which will be passed through the layer. So we have something like layer L is equal to new layer topology at I. Right? So since this is just an integer value, we'll use that information to tell the layer how many neurons it should make. So this layers dot push back L. Right, so now for the weight matrix, I just loop through topology size minus 1. Right? And then I'll just create a new matrix. Weight matrices. Okay, so this layers dot push back. No, not this layers push back. Tired. Matrix M equals new matrix. All right. So how will we know the number of rows and columns for this matrix? Well, if you look at this, the matrix here corresponds to this weight matrix here. So the number of rows will be the number of neurons to the left, and the number of columns will be the number of neurons to the right of this weight matrix, which is governed by the topology array. So if I wanted to create a new matrix, then the number of rows will be topology at index I, or at I, and the number of columns will be topology at I plus 1. Okay. And yes, I'd like to initialize random values for my weight matrix before pushing it into weight matrices. Okay, let's see if I implemented all the needed functions. Okay, this topology, well, I would like to store the topology, so something like this topology equals topology, right? And let's try to string everything together. For the layers, Well, there's one more thing, right? I'd like to set the input for 1, 0, 1. So maybe in the neural network, I'll have a function there called void set current input and pass to it the a vector of doubles to correspond to my input. Whoops. Okay, and then I'll have here a vector of double for my current input. Or rather input, just input will do. Okay, and then the implementation of that will be something like void neural network vector double input. This input equals input. Right, so once I initiate the input or assign the input values, then for a layer, so this layer at index 0, right, what I want to do is I'd like to set the input values for the neurons inside that layer. So what I'd have to do is do something like this, probably size I++. So this layer is at index 0, which is always the input layer. I'd like to set value, right? Or set value for the index, right? So I know the index of the neuron, that given value input at I. Okay, so I think I'm missing another function for layers, for the layer class called set value. So void layer set val, and then it will pass the index and the index and the value, the actual value, so v. Okay, so the nice thing about this is, the nice thing about this is I can get the neurons for this layer at index I, set val to be double val, right? So I think this should work. Okay, well, I think I should also declare it in my header file. Public void set val int I double v. Okay, so that will allow us to set a value for the neuron at some index I in a given layer every time we set the neural network's input. So this one should be something like neural network set input or set current input, I believe. All right. I think we can test this out. I'd like to have some print functionalities first. Well, there's another thing. This, when we do feed forward later on, we'll have to do some matrix multiplication. So we'll have to treat this this vector, which is the input layer, as a matrix, as a 1/3 matrix. So maybe we can have a function in the layer called matrix. It will return a matrix, a matrixify. Matrixify, okay. So include matrix.hvp. And what this will do is it will create a matrix for this given layer, a matrix representation for this given layer. Okay, so we'll have something like matrix layer matrixify. What can we do with this? Well. Actually, we need matrixify vals, matrixify activated vals, and matrixify derived vals, right? Because remember, the neuron will have a value, an activated value, and a derived value. So these are actually helper methods for us that we can use later on. Okay, so we have matrixify vals, matrixify activated vals, and matrixify derived vals. Okay, so for matrixify vals, we'll first create a new matrix of what's the size? It will always be 1 by the number of neurons for this given layer. There it falls. Okay, same goes for this one. Okay, so once we have that, then we'll fill in the matrix, right? So we'll loop through the neurons. For int I equals 0, I is less than neurons size, this neuron size, I plus plus. Okay, we'll set the value, right? I forgot the syntax. Matrix, set value, row call the value itself. Okay, set value, short-term memory loss, set value. Okay, set value, this neurons, let me see if I have this correctly, at I, okay, get val. Do I have a get val for the neuron? Right, get val, get activated val, get derived val. Okay, so get val, well, that will be for the value, but for the row, that would be always row 1, right? Always row 1, and I, which will be the column. All right. Okay, so we can have the same implementation for matrixify val. Oops, sorry. Matrixify activated val and matrixify derived vals. This one will be get activated val, and this one will be get derived val. I think this will prove useful later on when we do our feed forward and back propagation. Okay, so let's test these things out. Well, first I have to test if it compiles. Please compile. Why didn't it compile? All right, because I think I need to include neural network here. Neural network. Okay, and then in my main class, or in my main function, I have to include neural network here. Okay, so let's try to create a default neural network. We need a topology. Topology.pushback 3, 2, and 1. Oh no, sorry, 3, 2, 3. So it becomes consistent with this one. Okay, so we have the topology there, and then we can create our neural network. NN equals new neural network topology. Okay. So let's see if this compiles. Well, we'll also need the input, so something like vector double input.pushback 1 0 1. Okay, and then we say something like set current input to be input. Okay, so let's try this out first. Let's see first if this compiles. Oh, why can't it find neural network.cpp? Neural, oh sorry, wrong spelling. Neural net. Oh, press escape. Okay, it's wrong spelling here. Neural network. Okay, let's try that again. please compile. Okay, L was not declared. Neural network line 23. 23. Pushback L. Why? Oh, okay, okay. New layer. Push M, not L. Okay. Alright, so compile this, please work. Function, set current input, undefined reference to layer or neural network. Okay, so maybe I forgot to define in my header file for neural network what a layer is. Oh wait, I have it right here. What's wrong? Undefined reference to layer set val. Oh, layers at set val. I don't have a set val. Yeah, I have it right there. Let me open up. Okay, it won't compile. Alright, let's see the error again. I don't have set val. Right. I don't have it here. Right. Yeah. Okay. 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 I have it here. Set val. Should I include it? It's weird. Set val, set val. Int I double V, neurons at, it's the same signature. Oh, there's another error, undefined reference to layer. Did I not include it in neural network? I have it right here. Okay, this is weird. I think, okay, let me just guess it here. Right. I don't have the, okay, so the reason it won't compile is because it doesn't know the implementation for the layer class. So I forgot to include it in the cmakeLists.txt. Okay. Oh, did I close Vim? Alright, I also have another error here for the neuron class, or for the layer class. Layer. I think it's this one. There should be an arrow symbol instead of a dot. Okay, so I think this should work. Please work. Please work. Okay. Okay. Alright, so let's test this out. First, we created a new neural network, and let's say I have a print console as well for the neural network. Okay, so maybe this is the last method I'll be implementing. Void print to console, so that I can see what this network looks like. Okay, so in neural network, I'll have something like void neural network print to console, and all this will do is we can loop first through layers and then print the matrices in between them. So okay, so I'll first loop through the let's see, this layers.size I++. Now what I want to do is I'll have a matrix for the input layer. So if I is equal to 0, actually I can move this out here. If I is equal to 0, then get the matrixify. Yeah, I think I can finally use the matrixify function. Matrixify vals. Okay, I just want to get the raw vals, not the activated vals, for the input layer. And I know that we're in the input layer because we're at index I, or at index 0 of the layers. Okay, so matrix M is equal to matrixify vals, and I'll just do M print to console. Okay. So this one will print out the layer at index I. Now for each layer, well rather, if I is not equal to this, well, I'll just try to print the layers first. Else we'd like to print out the, this one will be the activated vals. Activated vals. Okay, print to console. Okay, let's test this one out first. We should have something like 3 to 3, wherein this one will be 1 0 1. This one will be something like 0 0 and 0 0 0 as well. Okay, so let's see if this compiles. Please compile. Okay. Oh, sorry. This layers at I matrixify vals. At I matrixify activated vals. Okay, let's try this again. I'm getting hungry. Okay. Instance layer 0. Okay, so we have an error when matrixifying the vals. Let's see. Oh, well, of course, we forgot to return the matrix. Alright, we forgot to return the matrix. Return M, return M, return M. Well, I don't think that was the error, but yeah, it's not the error. So, maybe this one. M set val. Well, it should work. Let's try this out. You have an index out of range. I'm not sure where it is, so let me just try something. This should print out the console. Right, so it's 0 0 0. Whoops. It's too much. Alright, so this one works. Maybe this one is not firing. So maybe set val is not firing. No, set val works. Matrix at I. Neurons. What is size of neurons? Maybe it might be 0. No, it's 3. Oh crap, sorry. Okay, let's check this out. Size 3, so we're looping 3 times. And what we want to do is we want to set the val at row 1 for this matrix. Index I. Neurons I false. Let's see if we're actually looping correctly. This doesn't make sense, but this size, which is 1. Who is size 1? Size of my matrix? Maybe set value is incorrect. Matrix set value, set val. Oh. Matrix. I I don't have a set matrix, a set value. Why don't I have a set value? Yeah, because it's here in my header file, I think. There, set value. This values at row at call is equal to v. That's weird. Okay, let me try something out. Let's see now. Okay, so there's something else. So we have an index out of range problem. Values that are at C, right? Row call. This is weird. The number of rows for this matrix. Let's just see the size of this matrix so we can better debug. Now calls. It terminates anyway after the whoops. Get num rows, sorry. Get num rows. Get num calls. Right, so let's try this again. 1, 3, yeah, it's a 1 by 3 matrix. Let's see, where's it? Neuron size, it's looping 3 times. This is the value. This neurons at I get val. That's for the layer, right? Right? Or inside the layer, right? So get val. No, it should be get activated val. No, rather. No, yeah, get val. The layer should have a, rather the neuron should have a get val, which just returns this val. Oh, it should be correct. Okay, let's debug it more. See out V and line. Oh, shoot. There, 131. Right, so where am I printing that? Right, 131 set val return m. So I think this is working. But when I called it in neural network, or rather in main, or neural network print, right? Layer set size at I. Trixify vals. Am I here? Let's try this again. So if it prints here, then there's something wrong with my print to console for matrix. Okay, so we're sure that it's not, sorry, we're sure that it's not at this point. So here in matrixify vals, that's where we're actually getting the mistake, unless, oh, that doesn't make sense, because we're already printing it from layer, right? Matrixify vals. Matrix M equals new matrix of row 1 neuron size false. What we're only doing here is we're setting the value for a matrix, right? Row call and the val. Double V. What's wrong? Still getting out of range. Why are we still getting out of range. V neurons at I get val, because we can print this, right? We can print this. This one is actually printing. Well, it printed out 1. If you don't have it here, everything's 0. So the bug is in the set val of a matrix. Set value of a matrix. This RC at, oh, it's weird. My set value is incorrect, but I know this was working earlier. What's happening in main? And print to console. Print to console is working. The set value doesn't seem to be working though. It was working earlier. Set value, get value, num rows, num calls. That's not it. Alright. Set value. This values at R, at some row index, which will always be 1, at C, the column am I doing that? No, I'm confused. I'm confused. Let's trace it again. Matrixify vowels, right? This layer is at I, so it's here in the implementation. New matrix row call neuron size 101 row call V. Yeah, it seems to be working. Why is it not working? Oh, oh. Well, that was the previous mistake as well. Oops, sorry. Is this not working? Let's clear this again. Get val size 3. It's always 1. Right? Because the size call count should be this neurons dot size, right? And then the size of columns will be the matrixified version, right? M get num calls. Right, so it's the same. 3 and 3. What the hell? Okay, so we're sure that this passing it correctly, but why when you loop through I0 double V get val, this one prints it correctly? Right? So there must be something wrong with my set val, because what I want to do is I want to set the value for a given matrix, right, according to the row, which is always, oh, okay, wow, rookie mistake. Oh, wow, rookie mistake, rookie mistake. It's not index 1, it's index 0. Okay, rookie mistake, rookie mistake. Okay, so the error there was that I was trying to set a val at row 1 when there is no row 1, right? There's actually no row 1. There is a row 0, which is the first index of the matrix or of the vector. So, okay, so always watch out for your array access or vector access. Okay, so this one should work. Please work. All right, so we have it right here. Just remove the C out right there, so it's much cleaner. Okay, so why is it printing out just 101? Right, so we have 3 layers, input output, right? And then the values are 0. Okay, so that's our neural network. I'll end the coding session right there. So what we did is we implemented classes for a layer for hidden layers and for the output layers, but basically they're just represented as a layer class. The weight matrix will be represented as a matrix class, and the entire neural network has its own class as well. Now, all these ideas actually came from a YouTube video. Okay, so just close this. Okay, so if you search neural network C++, okay, there are actually 2 nice videos out there for your neural network implementation. The first one is from Vinny Nguyen, hope I said that right, which is a C++ implementation as well. But the difference is that he didn't make use of matrices for the weight matrix. Okay, but the concept of layers and neurons as its own classes is also incorporated in this video, and it's actually a good video if you want to know more about neural networks, and implements the feed-forward and backprop as well as biased neurons, which I might get into in a later video. The other video is by this guy is awesome, Siraj Raval, wherein he implements a neural network, but this time in Python. Right? And he makes use of the TensorFlow library to implement the neural network. So if you want a quick fix on implementing a neural network, then watch his videos. He's really a cool guy. All right, so sorry for the lengthy video, but that's it for this live coding session. In the next session, I'll probably implement the feed-forward and output and backprop rather methods for the neural network. Okay, so that's it for this live coding session. And we'll end right there.